Hi guys. So today we are literally doing our lesson through this video. So the first part is just stuff that we have learned about, stuff you need to know. So everyone take a minute and fill in what would the derivative be in each of these cases. So first one is our power rule, derivative of x to the n, bring the n down and subtract 1. If there's some coefficient, so if this was like 2x to the n, then it would be 2n times x to the n minus 1. Coefficients just will get multiplied with that n. Now, if I have the two functions multiplying by each other, and I want to take the derivative of that, then we would use product rule, which is u prime v plus uv prime. So derivative of the first one, leave this one, plus leave this one, derivative of the other one. This one, derivative of something divided by something else, so two dividing functions, that's going to be quotient rule. So low, which in this case is v, d high would be derivative of the high one, which is u prime, minus high, u. D low, derivative of v is v prime, underneath the low squared, which is just v squared goes. Our trig derivatives, these are things we need to have memorized. Derivative of sine is cosine, derivative of cosine is negative sine. Derivative of tangent is secant squared, and derivative of secant is secant x tan x. There is cosecant and cotangent. They don't show up as much, so I just put the four main ones for right now. Number one is asking us to find this derivative and then to find f prime of pi. So everyone take a second, calculate derivative and then the derivative at pi. So pi over 2 in this case is just a coefficient, and then coefficients will just stay there. Derivative of sine is cosine. Now I have minus cosine. The derivative of cosine is negative sine, so I have minus negative sine, which becomes plus sine. Pi over 2 is just a constant, right? It's just a number, and the derivative of a constant or a number by itself is 0. So this is just pi over 2 cosine plus sine. Now I want to find f prime of pi, so you plug in. So pi over 2 cosine of pi plus sine of pi. Sine of pi is 0. Cosine of pi is negative 1. So this is negative 1 times pi over 2, which is just negative pi over 2. So there's your answer. I definitely always want to have like my f prime. I call it in terms of x, in this case theta, right? Before I actually plugged in the value of pi, and then you get your answer. Number 2, finding f prime of x. Think about, do you need to use any rule here? You can see I'm setting up my product rule. I'm identifying u and v because I have two functions multiplying that I want to take derivative of. So you guys finish that up. So my u prime, right, we would first of all get our u and our v. So x squared, and then cosine is the second one. Derivative of x squared is 2x. Derivative of cosine is negative sine. Now I just use my u prime v plus uv prime because that's what product rule tells me. So that's 2x times cosine plus x squared times negative sine. That just kind of looked weird, so I just rewrote it as 2x cosine minus x squared sine. I just always like to bring my coefficients out front of the term. Can't really simplify. You could factor out an x because this has an x, this has an x squared, but it's not really necessary, so I just left it there. Take a second, get the derivative of number 3. So this one, don't actually need to use any rule. It's just 3 times tangent. 3 is just a coefficient, so it stays there. It's 3 times. And derivative of tangent, we know is secant squared. So it's 3 secant squared x. For finding the derivative of this. So we don't know how to take derivative of like a function squared. So what we should do is we should actually multiply this out, box method or FOIL. So everyone, we're just rewriting it, right? Expanding it. So everyone do that. Once you've used either box method or FOIL or whatever way works for you, we should be getting 4x to the 6 plus 16x cubed plus 16. So I haven't taken the derivative, right? I've just expanded this. Now we can take the derivative. Hopefully you got this. Okay, so what we're talking about today, it's called chain rule. So chain rule is the rule to take derivative when you have functions inside of functions. So in this case, see how I have got this inside function and all of this is inside of the squared? In this case, I didn't really need to use chain rule because it's like, well, I can just square that and then take the derivative, no problem. But if I'm looking at something like 1a, definitely do not want to do box method 7 times to get all of this multiplied out and then take the derivative. That would be so much extra work. So we want to come up with, we're not going to come up with, I'm going to give you guys a rule for how to take a derivative when you have a function inside of the other. So our general form of the rule, if you have u of v of x, notice this is not u times v, this is u of v, so this is inside. So like this v is inside of the u. Then how you take the derivative of something like this is you take the derivative of the outside. So in this case, my outside function is u. So this would be derivative of u, which is u prime. You're going to leave the inside alone. So it's going to be u prime of the v of x. And then you're going to multiply by derivative of the inside. So this would be u of v. The derivative is going to be u prime of v times v prime. So I'm going to make a note. This is derivative of the outside, leave the inside alone, and then times derivative of the inside. So here, that is literally what this says, right? Derivative of the outside, so derivative of u prime, leave the inside alone, so it's u prime of v, times derivative of the inside, which is just v prime. So an example, let's go back up to number 4 and we're going to use chain rule and hopefully we get the same answer. So here, I'm going to rewrite it, 2x cubed plus 4 squared. So this was my function. My inside function here is this guy right here. So if it makes you feel better to label v as your inside, that would be 2x cubed plus 4. Take the derivative to get the derivative of the inside. Derivative of 2x cubed plus 4 is 6x squared. I almost just said 8x squared. Okay, so now what we're going to do when we take the derivative, this is absolutely a chain rule situation because I've got the 2x cubed plus 4 inside of the squared. So I know for the first part, I actually leave the inside alone. I only take derivative of the outside. The outside function is this squared. Derivative of squared, you just bring the 2 down, subtract 1, now it's to the 1 power. And then I know that I leave the inside alone. So this will just be 2x cubed plus 4. So now I have the first part. I took the derivative of the outside, bring the 2 down, subtract 1. I left the inside alone, the 2x cubed plus 4. And then last step is I need to multiply by derivative of the inside. I already found derivative of the inside, so it's times 6x squared. Now this is kind of not a super neat answer. So what I'm gonna do is this is just to the 1 power, right? So you don't have to write it there. I'm gonna distribute my 2 and distribute my 6x squared. So the 2 distributed would be 4x cubed plus 8, and then times 6x squared. Yay, I get the same answer. So again, this is a case where like it actually probably was easier to just multiply out and then take the derivative, but chain rule would work just as well. Now for number 1a, right, I'm not gonna do box method 7 times to expand that in order to take the derivative. So 1a, I definitely need to use my chain rule. So everyone take a second. What is my inside function? And then what would the derivative of the inside function be? It's actually the same inside, so the same derivative. Inside here is the 2x cubed plus 4. Derivative of that is 6x squared. Now, my outside function is different than the one we just did because now this is being raised to the 7th power, not the 2nd. So everyone just write the first part, the u prime of v part of our derivative. I'm raising it to the 7th power. You know how to take the derivative of something to the 7th power. You bring the 7 down and you subtract 1. So this is now a coefficient of 7 and now a power of 6 because I brought the 7 down and subtracted 1. Now the inside, what goes in the inside? Well, the chain rule tells me leave the inside alone. So I'm not going to do anything to the inside right now. I'm going to leave it as 2x cubed plus 4. So this is just the first part, right? The derivative of the outside, leave the inside alone. That's not all of it because chain rule also has times derivative of the inside. So then what I'm going to do is going to tack on at the end times derivative of the inside, which we just said was the 6x squared. Now, this is not a case for distributing the 7 because this is to the 6th power, right? So if you think about your orders of operations, this would be raised to the 6th, then distributing. I'm not going to raise it to the 6th, just leave it. But I can combine like all of this is being multiplied by 7 and 6x squared. So you can say, oh, that's just 42x squared. I always like to write like my coefficients, basically the stuff like that's not binomials or whatever in parentheses. I always like those terms out front. But if you had 42 this times the x squared at the end, it doesn't matter. It's just kind of standard way of writing. Yes, I'm done because I did derivative of the outside, left the inside alone, and then I multiplied by derivative of the inside. And I made it look nice. So lots of practice using chain rule. This is a case where I need to rewrite this. Like I can tell what my inside function is, so everyone can write my inside function and my derivative. So do that. Hopefully you said 3x minus 7 is your inside, and then derivative of 3x minus 7 is just 3. Now my outside function, I know my outside function is the square root, but I don't know how to take derivative of square root. I only know when it looks like the x, or in this case, inside to some power. So think about the square root of 3x minus 7 is just 3x minus 7 to the 1/2 power. All right, now this is set up nice and easy to use my chain rule to take derivative, my inside, my outside function, derivative of the outside, leave the inside alone, times derivative of the inside. So everyone is trying this one. So here I'm taking the derivative of the outside, which is to the 1/2 power, derivative of something to the 1/2 power, I bring the 1/2 down. This is 1/2. And then I'm going to subtract 1 is just going to give me negative 1/2. Now I'm not done, right? I have to go in and put what the inside is. So chain rule, derivative of the outside, leave the inside alone. So this is just 3x minus 7. But I'm still not done. That's just that first part, right? The like u prime of v. Now I need to multiply by derivative of the inside, which is just the 3. So derivative of the outside is the 1/2, and then now this is to the negative 1/2 power, left the inside alone, then multiply by derivative of the inside, which derivative of the inside was just 3. Everyone take a second, rewrite that, like clean it up. That looks nasty. I always bring my coefficients out front, so 3 times 1/2, just 3 over 2. 3x minus 7 is all to the negative 1/2 power. So negative means it goes on the bottom. So this 3x minus 7 goes on the bottom. 1/2 in your power means the square root. So this is 3 over 2 root 3x plus 7 minus 7. And that would be your derivative. So you'll see I'm just like using basically power rule, but also with chain rule. So derivative of the inside or outside, leave the inside alone, then multiply by derivative of the inside. All right, you guys try C, D, E. If you need to pause because I'm about to go through it, that's okay. Okay, for C, so we've got all of this to the 5th power. This is definitely chain rule, right? You've got this whole function inside of a function. The 5th power is like your outside function. So then derivative of the outside is bringing the 5 down and subtracting 1. So now it's to the 4th power, and I left the inside alone. And then I multiplied by derivative of the inside. Derivative of the inside was the 12x squared plus 3. And not really much you can do to clean that up. You can't distribute the 5 to this term because it's all to the 4th power. You could technically distribute the 5 here, but like it doesn't make it any neater. So then this is your answer. D, I had to rewrite it because square root of something cubed is just that something to the 3/2 power. So definitely chain rule because I've got an inside function and an outside function. This is the inside, x to the 4th plus 2, raised to the 3/2 power is like your outside function. Taking derivative of the outside, so to the 3/2 power, you would bring the 3/2 down and then you would subtract 1. 3/2 minus 1 is 1/2. So that's where that 1/2 came from. You're like, where did that come from? Those look like 5s. That's a 3. Okay, so that's the first part. Derivative of the outside, left the inside alone. Then you multiply by derivative of the inside, and inside is the x to the 4th plus 2. Derivative of x to the 4th plus 2 is just 4x cubed. This you could maybe rewrite and make it look a little nicer. So you guys try that one. So this x to the fourth plus 2 to the 1/2 power, this is positive, so it stays on top, right? It doesn't go in the denominator, and 1/2 power means square root. So I was like, oh, that's just a square root of that. I'm going to look at my coefficient. So I have 3 halves times 4. 3 halves times 4 is just 12 halves, which is 6. So then I have a coefficient of 6. And then I also have an x cubed. I always like to write like the x cubed, except for x squared, x's that are by themselves, not in like parentheses out front. Doesn't really matter, although it feels weird to be like the root of that times x cubed. Just bringing it out right. You guys, if you haven't done E, take a minute to finish up E. -7, just a coefficient. The 2x minus 3 is getting squared on the bottom, so that would be just 2x minus 3 to the -2 power. This is just rewriting, haven't taken any derivative, just rewrote it. Now I'm going to use my chain rule because I've got the inside function of 2x minus 3 to the outside function of -2 power. Bring the -2 down. -2 times -7 is +14. Leave the inside alone, and we subtracted 1 from the power to get -3. If you're like, where did that 2 come from? Remember, chain rule is derivative of the outside, leave the inside alone, then multiply by derivative of the inside. Derivative of 2x minus 3 is just times 2. Cleaning this up, 14 and 2 can just become 28. And then 2x minus 3 to the -3 power means 2x minus 3 cubed, but in the denominator. And there's your derivative. Okay, so now I want everyone thinking about part F. How are we going to take the derivative there? If you're thinking product rule, you're right. I am absolutely using product rule. You've got this function times this function. So my u would be like the x squared, and my v would be the 2x minus 4 cubed. Now, derivative of u is very straightforward, just 2x. Derivative of the v, so here, this is actually product rule and chain rule, because in this term, you've got a chain. You've got a function inside of a function. So now you're going to be taking the derivative of this using chain rule in order to then use product rule. So everyone just do the derivative of this to get v prime. Derivative of the outside is going to be this cube, so that would be 3, subtract 1 squared, leave the inside alone. Then we need to multiply by derivative of the inside. Inside is 2x minus 4, derivative of that is just times 2. So then this, just going to rewrite this as 6, 2x minus 4 squared. All right, now I have my u prime, v prime. Now I'm going to write my derivative for y by using that product rule. So everyone substitute in. So just literally substituting in u prime was 2x times v, which was the 2x minus 4 cubed, plus u, which is x squared, times v prime, which we kind of rewrote as 6, 2x minus 4 squared. Now this is your derivative, but if we're talking about multiple choice, we want to kind of clean this up, and it is possible to clean this up by factoring. So I have a common factor of a 2x minus 4. So this one is 2x minus 4 cubed. This one is 2x minus 4 squared. So think about how many 2x minus 4s do they have in common? Hopefully you said squared, because 3, right, you can pull 2 out, and 2, you can pull 2 out. So then everyone writing what's left when you factor out a 2x minus 4 squared. So first term, you'd be left with the 2x, and then you have 2x minus 4 left because this was cubed and you only pulled out a squared. And then here, you pulled out everything except for the 6x squared. Distribute this guy. And that is a clean, nice answer. You also might notice that they have an x in common. You could pull out an x as well, like this. I think I have that on my key. But either way, like these are pretty simple or pretty factored, nice answers. Okay, number 2. So now we're starting to look, okay, what if it's not just like algebraic functions, but like named functions? So in this case, you have h of x is f of g of x. So definitely chain rule. You've got one function inside of another. That's not multiplication. That is composition. They're inside each other, making a little chain. So I want everyone to write your h prime of x before you're plugging in at 0, just writing the derivative in terms of x. Okay, derivative of the outside. The outside is f, so derivative of the outside would be f prime. Leave the inside alone. So this is just of g of x, right? So I'd leave it alone. Then multiply by the derivative of the inside. The inside is g, so derivative of the inside is g prime. Derivative of the outside, leave the inside alone. Then multiply by derivative of the inside. All right, now you can plug in at 0, so get your answer. So remember, for f prime of g of 0, that is not f prime of 0 times g of 0. That is very different. This is literally f prime of g of 0. So you have to find g of 0, which in this case is 0. And then you find f prime of 0, because that's the new inside. And f prime of 0 is 2. Then I also have this times g prime of 0 term. G prime of 0 is 3. So then this is 2 times 3, which is 6. So you have to have this, and then you also need to have your answer, 6. Just careful, this is composition. They are inside of each other, not multiplying. Okay, number 3, we are practicing our chain rule using trig functions. So it's super important you kind of identify what is my outside, what is my inside function here. So if you still like to be writing like the inside as v and then finding derivative of the inside, v prime, totally fine. Here, think about what's my outside, what's my inside for number A, letter A. Hopefully you said the inside was 3x, and then therefore derivative of 3x is just 3. So then now use your chain rule, derivative of the outside, leave the inside alone, times derivative of the inside to get y prime for A. So derivative of the outside is definitely the cosine. Derivative of cosine is negative sine. And then I was told to leave the inside alone, so it's negative sine of 3x. And then I multiply by derivative of the inside, and I know derivative of the inside is just 3. So derivative of the outside, leave the inside alone, then times derivative of the inside. So rewriting this, I always bring my coefficient out front, so this is negative 3 sine of 3x. Now you might be wondering, wait, but it asks for this dy dx, and I forgot to mention, this is just the same as y prime. It's another notation for finding derivatives. So you've got you've got f prime, y prime, dy dx, similar to when you're saying like d dx of something. It's just asking for the derivative. So this is just another way of saying the derivative of y. right? You guys try B, C, and D. I think I changed this. So trying B, C, and D, and then I'll jump in a minute. Okay, for B, we've got 2 times sine of 3x. 2 is just a coefficient, so I'm just going to put the 2, right? It's a coefficient out front. Now, sine is my outside function, so I need to do the derivative of sine. Derivative of sine is cosine. I need to leave the inside alone, so it's still times of 3x. And then last step, I multiply by derivative of the inside. Derivative of the inside is just 3, because derivative of 3x is 3. Then this is just 6 cosine of 3x. C, super similar. I identified my inside as 5x squared and derivative of the inside is just 10x. So now to take my derivative, that's what dy dx means. If you write y prime, same thing. It's just asking for derivative. Outside derivative, derivative of cosine is negative sine. Leave the inside alone. So leave it as 5x squared. Then multiply by derivative of the inside, which we said was 10x. So this is negative 10x sine of 5x squared. D, we have secant of 7x to the 5th. I've identified my inside and derivative of the inside. Now I just need to apply my chain rule. So derivative of the outside, derivative of secant is secant. Did I say secant or tangent? I moved this to tangent, sorry. I changed it. Derivative of tangent is secant squared. Leave the inside alone, so it's secant squared of 7x to the 5th. And then multiply by derivative of the inside, and we already found the derivative of the inside to be the 35x to the 4th. I'm not going to rewrite that one. If you want to, you can move this out front so it looks better, but save the time. Right, you guys try E, finding derivative of secant of 4x. Here, my inside is just 4x, so derivative of the inside is just 4. What's tricky about this one is maybe the derivative of the outside. So we know the derivative of secant is secant tangent. So I always call it secant tangent, but it's technically secant of x times tangent of x, which means that if I'm leaving the inside alone, then it's secant of 4x times tangent of 4x, because that inside, right, secant of tangent of is staying the same. And we know that chain rule says derivative of the outside, leave the inside the same. And then last step is multiplying by derivative of the inside, which is 4. Again, you can rewrite this with 4 out front, but I'm just trying to save time in this video instead of you watching me writing. So this one just can be a little tricky because derivative of secant is actually 2 terms, secant of, tangent of, and the of, the inside, the 4x stays the same. You guys try F. Here, -2, just a coefficient, so it stays there. Derivative of tangent is secant squared. Leave the inside alone, so secant squared of x squared, and then multiply by derivative of the inside. Derivative of x squared is 2x, and then I just multiplied the 2 and the -2 together. All right, G is a little bit tricky because we're trying to find the derivative of sine squared of 3x squared. So think about, in this case, I actually have more than one inside. I have really 3 chains. So normally it's just an outside and inside. Think about, in this case, what is my like most outside function? The totally outermost outside function. I think some of you probably said the squared. Some of you might have said the sine. Remember, we write this squared to mean that this sine of 3x squared is getting squared. So I like to rewrite it like this. So now it's very easy. Like, okay, that's my outside function. Then the sine is inside, but inside of the sine is the 3x squared. So we're going to apply chain rule actually like twice because I have 2 insides. So we're going to just trust the chain rule. Chain rule tells me derivative of the outside, leave the inside alone. So my outside, like real outside function is the squared. So derivative of something squared is bring the 2 down, subtract 1. So this is 2, and then now this is to the 1 power, and it says leave the inside alone. So leave it alone, sine of 3x squared. Derivative of the outside, derivative of the outside, leave the inside alone. Now, the second part is I need to multiply by derivative of the inside. So I need to find what derivative of this is. So I'm going to off to the side say, okay, I'm looking at sine of 3x squared. What's derivative of sine of 3x squared? This is where I'm like applying chain rule again. Derivative of the outside is is cosine, because derivative of sine. Leave the inside alone, and then multiply by derivative of the inside. So this 6x. And then that's my derivative of the inside for here. So this is just what I'm putting here. Cosine of 3x squared times 6x. So, and then we can rewrite this as combining the 2 and the 6x to make 12x. So I had a lot of terms here because I actually had like 3 chains instead of just one function inside of an outside function. I've got outside, in, and then another in. So I had to do derivative of the outside, leave it alone, times derivative of the inside, leave it alone, times derivative of another inside. So I really kind of had to take the derivative like 3 times instead of just 2, outside, leave, and inside. Okay, we'll do more of those, I think, on like Monday or Tuesday or whatever. You guys try H and I. You can see my rewriting before I take the derivative. Okay, here square root of cosine is just cosine to the 1/2. So my inside is cosine, my outside is the 1/2. So derivative would just bring the 1/2 down, subtract 1, which gives me negative 1/2, and I'm leaving the inside alone, which is cosine. Then that's just derivative of the outside, leave the inside alone. Then I need to multiply by derivative of the inside, which is negative sine, because derivative of cosine is negative sine, and then take a second to rewrite. One half, right, just means 2 on the bottom. Negative sign on top is just negative sign on top. This cosine was to the negative 1/2. Negative means it goes on the bottom. 1/2 means square root. So this is negative sine over 2 root cosine. This one is another 3 chains, so I kind of have like a lot of derivatives to do. So chain rule tells me derivative of the outside, leave the inside alone. So the 1/2 gets brought down, and then this is now negative 1/2, and I'm leaving the inside alone. Then I need to multiply by derivative of the inside. Derivative of sine is cosine of x cubed. but there's still one more inside, so I need to multiply by derivative of the inside, which is 3x squared. So then now we can just combine the 3/2 x squared. Oh, no. Cosine of x cubed. And then this sine of x cubed is to the -1/2, so that's square root in the bottom. Like I said, we'll do more practice of like the 3 chains later on, because I want us definitely to do number 4. So everyone is writing out your derivative in terms of x. Derivative of the outside, g prime, leave the inside alone of f, times derivative of the inside, f prime. Now you're plugging in at 3. And then keep going, guys. You can kind of pause. So for 5, derivative of the outside is the squared. So bring the 2 down. Now it's to the 1 power. Leave the inside alone. Then multiply it by derivative of the inside, which is f prime. This is to the 1 power, not a prime, by the way. That is a very different thing, which to the 1 power doesn't really do anything. So then now this is just 2 f of x times f prime, plugging in at 1. All right, and we've got g of x, so derivative of the outside, leave the inside alone, times derivative of the inside, which is also g. So this is my n prime of x, plugging in at 3. What is g prime of 3? G of 3. G prime of 8. K, oh no. Sorry, my laptop was about to die. Okay, K, or number 7, we're looking at the square root of f. So just rewrite this as x to the 1/2 power, sorry, not x, f to the 1/2 power. And then now you can apply your chain rule because we have an inside f to the 1/2 power is like the outside. Derivative of the outside is 1/2 now to the -1/2 power when you subtract 1. Leave the inside alone. Derivative of the inside would just be f prime. Definitely rewrite this before you're plugging in. F to the -1/2 power means there's a 1/2, right? So 1/2. F to the -1/2 power means in the denominator and in a square root. And now you can plug in. Here it's just square root of 1, which is 1, so it doesn't really matter. So it's 1/2 times -3, which is -3/2. L, still chain rule, because we've got inside functions. So derivative of the outside, leave the inside alone, times derivative of the inside. And now we just plug in at 3. Here, -5 times pi is just -5 pi. Always make sure you have your this line, the derivative in terms of x, because then if you mess up your simplifying or what numbers you plugged in, you can at least get half credit. If you're just doing numbers, like, and you get the wrong answer, you get 0 credit. I can't find, like, it's just always best practice. And sometimes they like won't take the answer unless you have this. So like always best practice to do that.